they're telling you, write the equations of the line passing through the point P with the direction vector T. So you see, they're telling you, okay, the direction vector for the line is D equal. They're going to ask you on the vector form and parametric form. So you see, on WebAssign, you can tell here's the vector form, and here's you're gonna write down the parametric form. But if you look here, here's the forms. Here is the vector form, and here is the parametric form. Because on the test, you have to know these forms. Vector form, here is x, which is just xy. If you look to here, here is the xy. P is going to be 1, 0. So 1 here and 0 here. T, and here is the D. You're just going to put, this is D1, -1, and D2 is going to be 8. So I'm going to put down, here is because here is going to be P, which is the point 1, 1, and 0. And T is going to be, D is going to be -1, and the point is going to be 8. So this is the vector form. Let's check how we're going to write down the parametric form. I told you we can extend that from the vector form, we can find the parametric form. So let's check that. 1 second. So again, let's do that again. X, Y, P, this is the vector form. So 1, 0, and here is -1, 8. Now, how am I going to extend that to get the parametric form? So let's check that. So X, just going to multiply X equal, if you look here, it's 1 plus T times -1. That means it's going to be 1 minus T. Because -1 times T is going to be -1. The second one, the second parametric equations is going to be Y equal. There is no X. There is no point here because it's 0. So it's going to be just 8T. So these are the parametric equations, and you can just, if you want to just plug in using the formula, P1, which is 1 plus T, D1 is going to be the 0, the -1. And you can say Y equal P2 is 0, T times D2, which is 8, so it's going to be 8T. So here, you're just going to write down the parametric equations, which is X equal 1 minus T, 1 minus T, comma, Y equal 8T. That's it for this equation. But you have to put comma because it's going to be wrong. Let's go to the next one. The next questions. Now, exactly the same thing, but with the 3-dimension. Write the equation of the line passing through P with the normal vector V, normal vector N, in a normal form and general form. So here is P, and here is the normal vector N, but they ask you in a normal form. That means 3-dimension. So I'm going to look to this one or this one. But N is a 3-dimension. X, you have to put X, Y, Z. And P is the point, you see, with 0, 1, 0. So the point P equal 0, 1, 0. The normal vector equal 8, 4, 1. So which formula we're going to write down? The normal form, which is we can say n times x, the vector x minus p, equals 0. N, which is the normal vector, is 8, 4, 1 times x as a vector, which is 3 coordinate, is going to be x, y, z, minus the point p. Then write down the point p as a 0, 1, 0, equals 0. So this is the vector form, the normal form. So here we're going to write down the normal vector, which is 8, 4, and 1. And here is going to be the point, which is 0, 1, 0. So you see, it's exactly here. This is the normal form. B, they ask you to write down the general form. How are we going to write down the general form from the normal form? We're just going to do the dot product here. So I'm going to keep going. I'm going to say this is the normal vector equal times. I'm going to find the difference between these two vectors. So x minus 0 is going to be x. This is y minus 1 and z equal 0. Then I'm going to do the dot product. X is going to be 8 times x. X is going to be 8x. 4 times plus 4 times y minus 1 and 1 times z plus 1 times z. It's just the dot product. So it's going to be 8x plus distribute here 4y minus 4 plus z is going to be equal 0. So distribute here, here is the z. Now keep the x, y, z on this side and move the number by itself to the other side. So it's going to be 8x plus 4y plus z is going to be equal 4. So this is the general form. So we got the general form from the normal form. So we're going to say 8x plus 4y plus 4y plus z going to be equal 4. This is the second one. You see, each example, they ask you different things, which is good. So we're going to learn all techniques. Give a vector equation of the line passing through these 2 points. So that means this is the vector form. If you look, vector equations, that means this is the vector form, just similar to this one, vector form. I have x, and this is the p plus t and d. The only thing we're missing here is the d. That's me. Here's the line. This is a question 3. Here's the line. They give you passing through these 2 points, point P and point Q. The direction vector is always a vector parallel to this line. So can I find a vector from the point P to Q? The P is the point 0, 1, -1, and the Q is a point -5, 1, 6. So the vector D is going to be a Q minus P. It's a vector between these 2 points and with the same direction to the line. So it's going to be Q minus P. Let's say that this. So the direction vector is going to be Q1 minus P1, so -5 minus 0, 1 minus 1, 6 minus -1. D is going to be -5, 0, and 7. So this is the direction D. Now I'm going to go back here and I'll plug in here. On the test, you have to write down vector equations. That's mean vector form. So you have to write down the whole thing. That's mean X, which is the same X vector, equal the point P plus TD. So here is the vector X is going to be the point P, 0, 1, -1, plus T times the vector D, which is -5, 0, 7. Don't confuse yourself, because you can write down the vector in a row form or column form. It's the same thing, okay? Row form or column form. So we're gonna write down here -5 and 0, and here is going to be 7. The line L, I'm just looking for A, yeah. The line L passing through the point P. Write down the point. The point P is equal 1, -1, and 1, and has direction vector. You see, that's mean here is the line, they're telling you, and here's the point P, and the line has direction vector T. So direction vector equal 4, 5, -1. Hey, they ask you, consider the plane P defined by the following. So now we have line. They give you the information for the line, P and D. Now, A, they give you another equations for the plane. 4x plus 5y minus z equal 1. And they're going to ask you, find the normal vector for P, for the plane. So I'm not going to confuse myself now about the line. Now we have line and we have plane with xy. Line, here's the information for the line. For the plane, I have the general form for the plane. Can I find the normal vector from the general form? Let's go back to the slides. Here is a plane. This is the general form. The normal vector, remember when I told you, is the A, B, and C from the general form. A and B and C. That's mean N, which is the normal vector, it's A, B, and C. So to find the normal vector is going to be 4, 5, and -1. But I have general form. That's mean the normal vector, which is it's going to be the coefficient for x, four, and 5, and -1. Sorry, 4, 5, yeah, -1. 4, 5, and now let's check here. They're going to ask you, what is the relationship between D, which is the direction vector on the line, and the normal vector? Let's T be a scalar. Check. Here is D, and here is the normal vector. The normal vector. Is that the same thing? So the relationship between T and N is going to be the first one or the second one, or you can say neither of both these. They are the same. So can we say that if we multiply D times N equals 0, or we can say that D equal T times N? This is really important. They are the same. That means T equal T times N, or N equal T times D. So if you multiply, if you consider T is 1, in this case, if T equal 1 as a scalar, that means D is going to be equal N, or N is going to be equal D. So I'm going to choose this one. But the important thing is here, this option, because this option, it depends about if the dot product between these two vectors equals 0, or the dot product between these T if it's equal N. I'm not going to care about T. T is a scalar. So if they are equal to each other, if you found D, the direction vector, equal to N, the normal vector, that means this is perpendicular. So write down this a note. If they ask you, what's the relationship between the line and the plane? Find the direction vector from the line, find the direction vector from the plane. If they are exactly the same, they are perpendicular. That means N perpendicular to the D. In this case, that means the line is perpendicular to the plane. So we're just going to say, you see, determine whether L and P are parallel, perpendicular, or neither. So it's going to be perpendicular. So that's the important thing. If they ask you, is the line perpendicular to the plane? What you're going to do, just going to find the normal vector, and the direction vector is going to be exactly the same. Okay, so this is the first note. Let's keep going on this example. We're going to do exactly the same thing on the second part. On B. Consider the plane defined by the following. Now we have different plane. find the normal vector for P. So the normal vector for this one is going to be N is going to be equal 5, -1, and 15. 5, -1, and 15. This is the normal vector. We can do exactly the same thing. What's the relationship between? So I'm going to add down the vector first, which is 5, -1, and 15. 5, -1, and 15. What is the relationship between D and N? So here's the vector D, which is equal 4, 5, -1. 4, 5, -1. It's the same vector here on the top. Now let's check what's the relationship between these. This one, not similar to this one. They are totally different vectors. So let's try to multiply. If the multiplication, so this option is not going to work. Let's check the multiplication. Is the multiplication equal to 0? So let's check that. The N times D is going to be equal 0. Here's N, 5, -1, and 15 times D, which is 4, 5, -1. Is going to be 5 times 4, going to be 20, plus -1 times 5, which is -5, 15 times -1, 15 times 0 is going to be -15. The result is what? 0. That means if you multiply N times D equals 0, I'm going to choose this one. And in this case, N is going to be parallel to D. So this is the next important things. If the multiplication between the normal vector and the direction vector equals 0, that means N is parallel to D. In this case, the line is parallel to the plane. So the line and the plane are parallel or perpendicular or neither, so it's going to be parallel. You do the same thing with C, and you have 4 options. Consider the plane P defined by the following equations. The normal vector is going to be 1, -1, and -1. What is the relationship between D and N? Can we choose the second one? So for C, the normal vector is 1, -1, -1. And we have the same direction vector, which is 4, 5, -1. I can't multiply this one by a number to get the direction vector, so I can't choose N equal T times D. We can't choose this one. Let's try. If we multiply N times D, is the result equal 0? So N is 1, -1, -1 times D, which is 4, 5, -1. So it's going to be 1 times 4 is going to be 4, plus -1 times 5 is going to be -5 plus -1 times -1 is going to be 1. And the result is 0. This case, N is parallel to D. That means the line is parallel to plane. Find a vector form of the equations and of the line in R2 that pass through this point and parallel to the line, this one. So if you look this one, the vector form. So here is going to be P. I already have the P, 3 and -2. So I'm gonna write down the P, 3 and -2. But what about the D? D here, the vector form, we have to write down the D. How I'm going to find the D? Steps here. So now they're telling you the line is perpendicular to the plane. Parallel to the plane. That means here is the line, which is the plane, 3x minus 4y equal 2. That means I can get the normal vector for this one is going to be 3 and -4. 3 -4. Well, here the point is 3 -2. Since they are parallel, the line is parallel to the plane. That means n times the direction vector is going to be equal 0. Yes or no? This one is the line is parallel to P. That means the normal vector times the direction vector is supposed to be equal 0. So the normal vector is 3 -4 times the direction vector is say d1, d2 equals 0. I'm going to do the dot product. That's means 3 times d1 plus -4 times d2 equal 0. 3 d1 minus 4 d2 equal 0. So how are we going to get how much is going to be d1 and how much is going to be d2 to make the result equal 0? Which number are going to plug in here and which number are going to plug in here to make the result equal 0? If you put 4 here, d1, if I put 4 here, 3 times 4, 12. If you put 3 here, 4 times 3 is going to be 12. That's means 12 times 12 minus 12 is going to be 0. That means D equal D1, D2 is going to be equal. D1 is 3 and D2 is 4. That's our goal. D1 is going to be 3 and D2 is going to be equal 4. That's 3 and 4. So where is the wrong thing? 3 -2, 3, 3 -2. So this one is 4 and this one is 3. Because this is D1, this is D2. Here's, we're going to do this as the last one. They ask you, find the distance from the point Q to the line L. This is really important. We're not going to do that in detail. Like I'm going to solve all the examples for you. Find the distance from the point Q to the line. So let's say here's a simple graph. Here is the point, here is the line. And here is a point Q. We need to find the distance between this point and the line. So we're going to assume that from the graph we have Q is 0, 2, and 0. And let's check to the equations here. X, Y, Z, this is the P. And this is the D. So they already give us P equal, which is the point on the line. Here's the P. It's a point on the line, which is 2 and 2 and 2. And they give us a direction vector. Direction vector D, which is the point -4 and 0, 4. Let's assume that this is the point R, and here's a vector B. I have this one, I can find a vector B. We need to find the distance here. We're going to use the projection. The distance is going to be the projection of V into PR. Okay, so our QR is going to be also. So let's check it out. First thing, V, the vector V is going to be PQ, which is equal the coordinate of P minus a Q. So it's going to be, let's write down Q minus P, and it's going to be, I'm just going to do it right away, Q minus P. That means 0 minus 2 is going to be -2. And 2 minus 2, that is the point. Yeah, 0, 2. Yes. So it's going to be -2, 0, and 0 minus 2 is going to be also -2. So this is the vector V. My goal is to find the distance. That means I need to find QRQ. Next step, the projection of V onto V, or the direction vector. So the projection of V, the vector V, to the direction vector D is going to be the dot product between dV over V times V I'm just using the projection rule. D times the vector. So we're going to apply D times the vector V. That means it's going to be, here is D, -4 times -2. Let's write down right away. So it's going to be 8. Plus 0 times 0 plus 4 times -2 is going to be -8. The vector V is wrong because it's 5 here. So it's going to be 5 times negative 2 is going to be negative 10 over d times the product of d with the d, so it's going to be 16 plus 0 plus 25. And the vector d is going to be negative 4, 0, and 5. That means is going to be, this is negative 2 over 16 plus 25 is going to be 41. So it's going to be negative 2 over 41 with the direction vector negative 4, 0, 5. And I think we had to simplify it. Yes. Multiply this one with the 4. So it's going to be 8 over 41. This is the projection, 8 over 41, 0. And the third one is going to be negative 10 over 41. This is the projection of V into this direction vector D. Then we need to find the RQ. We project this one here. Now you need to find RQ, which is the distance here. So we're going to say RQ is going to be the vector V minus projection to the vector D onto D. This one is going to be, the vector V is negative 2, 0, and negative 2, minus the new vector we have here, 8 over 41, 0, and negative 10 over 41. And this one is going to be negative 2 minus 8 over 41, 90 over 41. 0 minus 0 is going to be 0. And negative 2 plus 10 over 41. So it's going to be 82 minus 10 over 41. It's going to be negative 72. Yeah, it's going to be 82 over 41. So this is the length for this. I found the vector RQ. I need to find the distance. That means the length for this one is going to be the distance. So the length of the vector RQ is going to be square root of the first component square plus 0 square plus negative 90 over 41 square. And I'm just going to give you work on this one. The length is going to be a really big number, which is going to be the distance between Q, the point Q, and the line